Hello everyone, welcome to Best Classes. Hope all of you are well in this lockdown. And as we know that we all learn science regularly, and maths is a bit difficult without teacher. So today I just try my own video in front of you. So try to understand it, learn it, and prepare your own notes. But listen, you just watch this video 2 times and try to solve the sums. Is that clear, students? See you. Hello everyone, I am Mehul Gandhi, your maths teacher. Today we learn our first chapter, that is real number. But before dealing with real number, we just memorize some concept about numbers that we learn in previous standard. So our first chapter is a real number. So what is numbers? Numbers are countless, that is infinite many. We cannot count the numbers. Now types of numbers, as we all know that the natural numbers starting from 1 to onwards, whole numbers from 0 to onwards, integers contains all negative, all positive including 0. A rational number, the numbers which are in the form of p by q. It means that the numbers of the form p upon q, where p and q are integers. Integers means from these groups, and q is not equal to 0, are called rational numbers. For example, like 2 by 7 minus 3 by 8, 2, we can also take 2 as a rational number because 2 we can write as 2 upon 1, but practically we are not writing 1 here. 0 is also a rational number. These are rational numbers. Then we go with the irrational number. So the numbers which we cannot write in a form of rational, that we can say irrational number. It means that we cannot write it in a form of p by q, just like root of 2, minus root of 3, 1 plus root of 3, etc. Right? These are called irrational number. After that, we are dealing with real number. That is our first chapter, real number. So real numbers include both the numbers rational as well as irrational. Rational as well as irrational. This is our chapter, real number. So we deal with the real number. Before dealing with the real number, we go with 4 more terms that you already learn in 9th standard. The irrational number means non-terminating, non-recurring. And we all know about this 4 term. Terminating. Terminating means which has some end, like 1 upon 2. So we can write 0.5. That is called terminating number. Non-terminating number. Non-terminating means suppose you can do 1 upon 3. Then the answer is 0.3333 dash dash dash. It means that there is no end. That's why it is called non-terminating. Recurring. Recurring means a repeated number. See in this sum 0.333. This 3333 is a recurring number. And the last one is non-recurring. Non-recurring means 0.1347594 dash dash dash. So these 2 numbers, like non-terminating, non-recurring, is called irrational number. And the combination of irrational number and rational number is called a real number. So let's start our chapter real number. So real number. First we deal with the properties of positive integers. Now we are familiar with the integers, so we just go with the property of positive integers. So there is 2 important properties in our standard 10. First is called Euclid's division lemma. Euclid's division lemma. And the second is fundamental theorem of arithmetic. The fundamental theorem of arithmetic. So first we learn Euclid division lemma. I know that this is the first time you are dealing with such a type of name. The Euclid is name of mathematician. Division means division. And lemma means you can say it is a rule. So Euclid prepare or maintain some rules for division, and that is called Euclid's division lemma. Now go with the statement. So what is the statement of Euclid's division lemma? So given positive integers a and b, suppose two integers are given, but the integer must be positive because we cannot divide the negative numbers. Given positive integers a and b, there exists unique means one and only one, unique integers q and r. Unique integers q and r satisfying a is equal to bq plus r. A is equal to bq plus r. The condition is r is less than b, but r may be 0 or more than 0. I know that you are a little bit confused about this statement, what the statement said. So it is just like a simple division. We know the division. We know that 6 divided 5. So what we can do? Our regular method, that is 6 divided by 5. So 5 ones are 5. So remainder is 1. This 6 is called dividend. 5 is called divisor. 1 is called quotient. And here 1 is called a remainder. So this Euclid's division lemma is just like a simple division. As we know that in our simple division, that is a regular division, one is dividend, another is divisor, quotient and a remainder. So we know this equation, dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. That is a is equal to b into q plus r. A is equal to b into q plus r. Simple way, a is equal to bq plus r. So in Euclid division lemma, a is called dividend, b is called divisor, q is called quotient and r is called remainder. In this case, here m is k, 6 is equal to 5 into 1 plus 1. This 1 is remainder. The condition also satisfied. The remainder means k 1 is less than 5. 5 means divisor, but it may be 0 or it is greater than 0. Still confused? So just take one example for better understanding. Consider pair of integers 10 and 3. Take two numbers 10 and 3. We can write the following relation for this pair. If you divide 10 by 3, as 10 is bigger and 3 is smaller. So if you divide 10 by 3, so we can write 3 3s are 9. So remainder is 1. So what is here? 10 is equal to, means dividend is equal to divisor into quotient plus remainder. It means here 10 is equal to 3 into 3 plus 1. So here a is equal to b into q plus r, where r is less than 3 was greater than or equal to 0. Hope you clear your idea. Now what we learn from Euclid division lemma. So we just conclude that from above examples, we note that q and r can also be 0. Q and r can also be 0. Q and r are a unique. Unique means one and only one, where the condition as usual, r is greater than or equal to 0 but less than b. Euclid division lemma is nothing but a restatement of the long division process with a, b, q and r as dividend, divisor, quotient and a remainder respectively. Say students, if you still confused, go with the previous page and again understand the video properly. Watch this video again and again so you will get this idea, because it's a new chapter, right? But it is very simple. It is just like a simple division method. And the Euclid division lemma is a is equal to bq plus r. We can say that dividend is equal to divisor into quotient plus remainder. Now from that, another topic is Euclid division algorithm. And Euclid division algorithm means It is just a process to find out HCF with the use of Euclid division lemma. So this is based on Euclid division lemma. Euclid division algorithm is a technique to compare or to compute or to find out the highest common factor, that is, we can say HCF. You all are familiar with the HCF of the given positive integer. But remember student, our regular modern technique to find out HCF is not valid here. Answer is definitely same with the modern technique or with the Euclid division lemma. But in this chapter we find out HCF with the use of Euclid division lemma. Okay. Now we just start our textbook exercise 1.1, which is very easy, and see, understand it. Question number 1 of exercise 1.1. Use Euclid's division algorithm. I repeat, Euclid's division algorithm. It means that we have to find out HCF of 135 and 225 with the use of Euclid division lemma. Okay. So we have to find out HCF of 135 and 225. All of you are familiar with that simple regular method of factor method, right now? But we are not dealing with that method. No doubt answer is definitely same. But this is again a easy method. See here. First find out which out of these two, which one is bigger number. So 225 is bigger than 135. And that's why we can divide 225 with 135. So divide 225 with 135. So 135 ones are 135. So remainder is 90. Remainder is 90. The first step we can simply write as 225 is equal to 135 into 1 plus 90. That is dividend is equal to divisor into quotient plus remainder. That is 225 is equal to 135 into 1 plus 90. Now take these two, 135 and 90. Divide 135 with 90. So 135 divided by 90, that is our second step. So 90 ones are 90 is equal to 45. So we can write again dividend is equal to divisor into quotient plus remainder. That is 135 is equal to 90 into 1 plus 45. Now again 90 and 45. So bigger is 90 and smaller is 45. So divide 90 with 45. So divide 90 and 45. 45 twos are 90. So here our remainder is 0. So our sum is over almost. So we can write again dividend is equal to divisor into quotient plus remainder. So 90 is equal to 45 into 2 plus 10. So here remainder is 0. So we stop here. Our next step is not possible. So here divisor at this stage is 45. And the answer is 45 is the HCF of 225 and 135. Right? Just watch this sum one more time. See how we can solve this. It's a very easy. Simply we have to divide the bigger number with the smaller one. And we have to write dividend is equal to divisor into quotient plus remainder. In your textbook, 3 sums are given. So I will just give you to do it yourself, second and third number. Just try it and forward me. You just prepare your notebooks just like school or tuition notebook. Okay, just prepare a notebook, new notebook, and dictate all these things. I also sent PDF of this so to write clearly. Okay, now we just go with the question number 2. The question number 2. Show that or prove that any positive or integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Here q is some integer, so you can take q as any integer, but whatever is the integer, that is the multiple of 6. 6q means it's a multiple of 6, and multiple of 6 are always even numbers. But if you add odd numbers to that 6q, we will definitely get odd integer, and that we have to prove it. Hope you understand the question. Here it is given 6q. 6q means k multiple of 6. It is always even number, right? But if you add odd numbers, you will definitely get the final odd number, and that we have to prove it, that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. See, there are many types of method of this sum. We just go with the simple method so you can easily understand. Now see, what is our method? Let a be any positive integer. Let a be any positive integer and b is equal to 6. Whatever here it's a multiple is, we can take as multiple of q is known as b, multiple of q is known as b, because a is equal to bq plus r. A is equal to bq plus r is our Euclid's division lemma. So this is bq plus r. So r is here 1, here 3 and here 5, and bq means b is equal to 6, and whatever is the final answer is a, and that's why we can take a be any positive integer and b is equal to 6. By Euclid algorithm, we know that a is equal to bq plus r. A is equal to bq plus r, where condition is r is maybe 0 or greater than 0 but always less than b. Here b is equal to 6, that is r is less than 6 but greater than or equal to 0. So what is the possible value of r? Definitely it is less than 6. It may be 0 or greater than 0 but less than 6. So we can take r is equal to 0 to 5, that is 0, 1, 2, 3, 4 and 5. These are the most possible values of r. We cannot take value other than this according to the rules lemma of Euclid. So taking r is equal to 0, take this equation as number 1. Take r is equal to 0. If you put r is equal to 0, definitely a is equal to 6q, right now? A is equal to 6q. 6q means multiple of 6 is always even number. Take r is equal to 1 in equation 1. So a is equal to 6q plus 1. Whatever is the final answer is definitely odd number. So here we get odd. If you put r is equal to 2, you will get a is equal to 6q plus 2. If you add 2 in any even number, again you will get even number. So the final answer a is again even. Take r is equal to 3. So a is equal to 6q plus 3. Definitely if you can add odd number in even number, you will get final odd number. R is equal to 4, you will get even. Similarly r is equal to 5, you will get odd. So in this case, this one is odd number, this one is odd number and this one is odd number. That is 6q plus 1 is odd, 6q plus 3 is odd and 6q plus 5 is odd. And that only we have to prove that positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5. So here from above we saw that, or prove that any positive integer is in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. Now listen students, you just watch this video two times at least. Try to prepare your own notes, and these notes you have to write in your notebook in the same way that I have given to you in PDF form. Listen, try to do sums regularly, go with science, go with maths, language also you can try at home. Okay, see you again. Thank you very much.